Okay guys, I'd like to welcome you to another screencast. Sorry I can't be in today, but as I stated on Monday, I have to observe down at Benton High School. I want to start out by reminding you about the tutoring schedule. In case you don't recall, this thing is going to be hanging on room number 39, okay, which is Miss Dorsey's room. It'll say that on the outside, and it will also have my name on the outside too, because I do use that room. This sign's posted out there. The date on there right now is blank, but the first day available for tutoring is Thursday of this week, and so you need to sign up by Thursday. If you want to do the morning session, your tutor is going to be Shane. If you want to do the afternoon session, your tutor is going to be Tori. And wherever you want to sign up, if you want to do afternoon, if you want to do morning, you'll just put your name right on here. Okay? So that's that. Now let's go ahead and clear that out. We'll go back to our mouse and we're going to talk about our assignment on 8.1, 8.2. First off, we had product of a power, which meant that when they are being multiplied, such as you see right here, what you do is the base number stays the same and the exponents add. Therefore your answer here would be 5 to the 12th. Keep in mind it does say write your answer using exponents. Another example we might look at would be this negative example in number 2. We talked the other day about negative examples a little bit. Notice they're being multiplied, so the base number stays the same and the exponents add together. So therefore the answer here would be negative 4 to the 10th. Negative 4 must be in parentheses in order to be correct. Since you have a negative 1 there, I'll let you work that example. 8 to the 2nd times 8 to the 4th times 8 to the 1st. Remember, when there's just an 1/8 there, or maybe 1/2 there, its exponent is 1. So we would have to add all those situations, or all those exponents, to get our answer of 8 to the 7th, not 9th. 8 to the 7th power. And so there's your help on number 4. Okay? Let's go down on the front of this page and we'll take a look at some more difficult examples. Okay? If we're looking at the front of this page, we have some that don't have numbers as their base. Some of them have exponents. And if we're looking at those products of powers, it's the same thing. The base number stays the same. Here your base is x. So we will be adding the exponents together, 5 plus 2, and that answer would be x to the 7th. And the other ones that are similar would be here, here, here. These ones are being multiplied, and 24 is being multiplied, along with 10, 11. Okay, now let me switch colors here so that I can talk a little bit about a power of a power. The power of power shortcut allowed us to multiply our exponents. Now if we look at number 6, here's our first one that has a power of a power. Inside the parentheses you already have a power taking place. You have 3 to the 5th. Outside the parentheses it's being multiplied with another exponent. So it's one power to another power, and what we do there for our shortcut is we'll multiply the exponents, so this would equal 3 to the 10th. Okay, notice if we went to 7, hopefully you can see that the base is 9, the exponent or first exponent is 3, and it's going to be multiplied by the second exponent, which would give that answer there. Same thing in number 8, same thing in number 12. When we go down to 13 through 24, we're going to have variables this time. So if we look at 16, our base is p. First exponent is 3 times the second exponent is 7, and that's going to give you a resulting answer of p to the 21st power. Alright, so notice that's going to be the same on 17. 18 is a little bit special, and we'll come back to 18. 19 you should figure out. 21, 22, 23, and 24 kind of have a mix of them. So let's take a look at 18 first, since it's kind of a special situation. What happens in 18 is I have a base that is b plus 1. These have their own exponents. They're being taken to this exponent, and then there's a power to another power, which means they multiply. So then this is going to equal b plus 1, and all of that is going to be now taken to the 6th power. Now, because b has an exponent of 1 and 1 has an exponent of 1, what happens here is the power goes to that power, which means 1 times 6 plus 1 to the power of 1 times 6, and that all simplifies and reduces down to be b to the 6th power plus 1 to the 6th power, and 1 to the 6th power is going to be 1 times 1 times 1 times 1 times 1 times 1, and if we multiply 1 a million times or 6 times, it doesn't really matter because its end result is going to be 1. So the easiest way to write this in the simplest form is b to the 6th plus 1. Okay? Now 21 has some extra steps to it. It has a power of a power taking place. Base number 6 has an exponent of 1 because there's 1 6. X, there are 3 of them. For negative 4, it has an exponent of 1, and this x has 5 of them. So let's take this power of a power here toward all the exponents, and we'll have 6 to the 1st times 2, x to the 3rd times 2. Then all of this is being multiplied with that second one that's happening, which is negative 4 to the 1st times 3, because this exponent is power of a power with these, x to the 5th times 3. And now let me simplify these up top. We'll have 6 to the 2nd, because 1 times 2 is 2. X to the 6th, because 3 times 2 is 6. And it's all being multiplied with negative 4 to the 3rd, because 1 times 3 is 3. And then x to the 15th, because 5 times 3 is 15. Now, since all of these are being multiplied, that takes me back to my power of a power just like I was doing before. So I have 6 x's multiplying with 15 x's. That makes a total of 21 x's. Okay? 6 squared would actually be 36. Negative 4 to the 3rd would actually be negative 64. So you could multiply 36 and negative 64 to get this number. For right now, what I'm going to do is I'm going to leave it as 6 squared and negative 4 to the 3rd. And we'll leave that as the final answer. Okay, last one, 24. I'll help you on it. 4p squared just stays as is for right now, because we have this power of a power which needs to take place here. So 4p squared is going to multiply with 3 squared, because I took 1 times 2, and then p is now going to have an exponent. I hope you can see that 5 times 2 is 10. Now I have 2p's plus another 10p's, I'm going to bring these numbers together. 4 times 3 squared, and all this is multiplying with the total number of p's I have, which is going to be 12. Now if I did take 4 times 3 squared, that's 4 times 3 times 3. All of that's going to total to be 36. Since that's an easier number or a relatively small number, I'll go ahead and simplify that all the way down. Okay? And that's your help with lesson 8.1. When you get down here to these, since it's a product of a power, you're trying to find the variable, or not the variable, the exponent that would fill in here to make 6 plus whatever that exponent is to make 12. So if this exponent were 1, it clearly would not make 12 because that would be 6 plus 1, which is not 12. In this one, it's a power of a power. So what number times 4 would make 12? And in this one, it's another power of a power. What number multiplied with 3 would make 18? And that's good help on 8.1. So there's your first screencast. You'll probably have a total of 3 today, depending on how things go. I'm going to go ahead and stop this recording. If you got questions, the sub's going to be around to help. Take some time to work on 8.1. If you're done with 8.1, take some time to work on 8.2. Good luck.